Hello everyone, welcome back to the videos, and in this video we continue the recitation video where I will solve a problem for improper integral. So remember that for improper integral you will have three types of integral. You have three types of improper integral. The first type is the bound that you have. The first problem is the function that you want to integrate have the vertical asymptote that is contained in the intervals of integration. The second type is you will have one of the bound as infinity. Okay, so the ideas of solving this problem is you're gonna replace the bound where you have the problems by a new variable t, and you're gonna evaluate that new integral in terms of t, and after you get the final result you will use the limit. Okay, so over here you see that the numbers of integration that you have is from 3 to 7. I'm sorry, I will solve this one. The integral I want to integrate the interval I want to integrate is from 1 to 3, and my function have some problem at 1 because if I plug in 1, my function is not well defined, so my function had a vertical asymptote at 1. So to deal with this problem, I'm gonna replace the bound by t. Okay, I replace the lower bound by t, and I will let t tend to 1 from the right side. Okay, because 1 is the left endpoint, 1 is the left. I have 1 and 3. 1 is the left endpoint, and I will let t close to 1 as much as I can. So that means I will have 1 from the 1 plus, which is t approaches 1 from the right side. Okay, and now I have the x square root of x minus 1. Okay, so let's focus on this integration, and once you get the result, we can evaluate the limits. T go to 1 plus. You can rewrite your integration as x minus 1 to the power of negative 1 half. Okay, and then you t to 3, and you plug in the values. T minus 1 plus. Okay, the integrations of x minus 1 to the power of negative 1 half, you just need to use the power rule. You add 1 into your power, you have x minus 1 to the power of 1 half divided by 1 half divided by 1 half. And then you plug in the upper bound and lower bound. T to 1 plus. You have 3 minus 1 to the power of 1 half divided by 1 half minus t minus 1 to the power of 1 half divided by 1 half. Okay, and 1 half is just the square root. So let me rewrite that again. 3 minus 1 is 2. 2 1 half is square root of 2. Square root of 2 divided by 1 half minus square root of t minus 1 divided by 1 half. Okay. And when I let t tend to 1, I will have square root of 0, right? You plug in 1 over here. 1 minus 1 is 0, so this thing vanishes. You just simply have square root of 2 divided by 1 half, or 2 square root of 2. Okay, let's go into the next one. The next one, your integration have some things over here. I mean, initially you have to be careful. You have to pay attention to the vertical asymptote of your function. Over here, the vertical asymptote of your function is x equal to 0. But the point is, the intervals of your integration, the interval of your integration does not contain x equal to 0. So you just need to handle the problems where you have infinities on the upper bound. Therefore, I will replace the upper bound by t, and I will let t tend to infinity. Okay, x ln squared of x. Okay, now we focus on this integration, and I believe that you can do the substitution. Set up u equal to ln of x, therefore du will be 1 over x dx. Okay, that means the integration that you have over here is du divided by L divided by u squared, right? Because dx over x is du and ln squared is u squared. And you find the antiderivative, you have u to the power of -1 divided by 1, or you have -1 over u plus c. Okay, let me write that this one plus c. Okay, and u is ln of x, so I have ln of x -1 over ln of x plus c. And now I need to evaluate my integration at the upper bound and lower bound. So therefore, 1 to t, so dx over x times ln x squared d is -1 over ln of x from 1 to t. You plug in the bound. You have -1 over ln of t, subtract -1 over 1. I'm sorry, ln of 1. Oh, I'm sorry. I mean, I should have e, not 1. I'm sorry. E. Because if I have 1, things will become more complicated. I don't want to over adjust the question. Sorry for my confusion. If I cause any confusion, over here I have ln of e. Okay, for ln of e, so you're gonna have -1 over ln of t minus, minus give you plus sign, so you have plus sine 1 because ln of e is 1. Now I need to evaluate the limits. So the limits when t approach infinities of -1 over ln of t plus 1 is, so when t approach infinity, the ln function will approach infinity as well. So that means the entire fraction will go to 0. Therefore, your final number is 1. Okay. For the next one, you have x squared ln of x. Okay. And remember that the ln function has the vertical asymptote at 0. Okay. If you don't remember, this is the graph for the ln function. Okay, so they have the vertical. This function has the vertical asymptote at 0, and 0 appears in the lower bound. So this is the improper integral as well. Therefore, you have to do this one. Limits when t approaches 0 from the right. Okay, this is the left endpoint, so you're gonna use the limit from the right endpoint. From the right, t1 x squared ln of x dx. Okay, and for this one, I believe that you have to do the integration by part, right? Because you have two type of function. One of them is algebraic function. One of them is the log function. You set up u equal to ln of x and dv as x squared dx. Therefore, du is 1 over x dx, and v is x cubed divided by 3. The formulation for the integration by part is the limit. Let's just write it down again. The formulation for the integration by part is uv minus the integrations of v du. So u times v give me ln of x times x cubed divided by 3. The bound is t to 1. Subtract the integrals of v du. So I have x cubed divided by 3. X cubed divided by 3 times 1 over x dx. Okay, the integral is v du. So x cubed divided by 3 times 1 over x dx. T to 1. Okay, t to 0 plus. You plug in the bound. So plug in the upper bound. You have ln of 1. ln of 1 is 0, so I don't care about the upper bound. You plug in t. So you will have negative sign because t is a lower bound. You have ln of t times t cubed divided by 3. Subtract the integrations over here, which is t1 x squared divided by 3 dx. You take the integration. Firstly, I just rewrite this one again. The integration is x3 divided by 3. So I have 9, because 3 times 3 is 9. T1. Okay. And now I plug in the upper bound and lower bound. T tends to infinity. 0 plus ln of t times t cubed divided by 3 minus 1 over 9 minus t cubed divided by 3. Okay, so this limit is a little bit tricky, so I think you have to do the L'Hopital rule. But firstly, let's simplify the thing that we have. T 0 plus 1 ln of t cubed divided by 3 minus 1 over 9 plus t cubed over 3. Okay. T tends to 0 from the right side. You have t cubed divided by 3, 1 minus ln of t. Okay, I just factor out t cubed divided by 3, so I have 1 minus ln of t minus 1 over 9. And now what if we let t tend to 0? If you let t tend to 0, you're gonna have firstly, this limit is in terms of t, so you can take out the 1 over 9. So I would take negative 1 over 9 outside. Okay, and for this one, you're gonna use the L'Hopital rules because you have infinity times 0, which is the indeterminants. Okay, so we use the L'Hopital rules. So to use the L'Hopital rules, you have to do this way. You have to rewrite your limits as 1 minus ln of t divided by t to the power of negative 3. Okay, I bring 3 to the power of 3 into the denominator. Okay, And when I bring the something from the numerators to denominators, I will have the negative power. And that means I have 1 over t cubed over here. And now we're gonna do the L'Hopital rule. So when I do the L'Hopital rule, I will have the limit when t approaches 0, derivative of 1 is 0, derivative of ln of t is 1 over t, and I still have the minus sign in front. The derivative of this thing is negative 1 over t to power of 4. Okay. Minus 1 over 9. And 1 over t, the minus sign and minus sign cancel out. 1 over t divided by 1 over t over 4 will give me 1 over t cubed. Okay. So at the end, I will have the limit t to 0 of t of power 4 divided by t minus 1 over 9. So I have the limit when t approaches 0 from the right side of t cubed minus 1 over 9. And because t approaches 0 from the right side, so I plug in 0 and have 0 cubed, which is 0. So at the end, my final result is 1, negative 1 over 9. Okay? Okay, let's continue with the next one. So the next one, okay, again, over here, the bound is not infinity, so it should be type 2 for the improper integral, and you can see that your function had a vertical asymptote at 0. Therefore, you're going to replace the upper bound, I'm sorry, you're going to replace the lower bound by t. So the limit when t approaches 0 from the right side of t to e ln of x dx. So in this question, I just changed the bound, okay, upper bound. Instead of 1, I have e. But the idea is the same. Okay, so let's focus on this integration. And again, I believe this one, you can use the u substitution, because if you set up u equal to ln of x, when you check derivative, you're going to have dx over x. Okay, set up u equal to ln of x. Therefore, du will be 1 over x dx. Therefore, the thing you want to check the antiderivative will be du divided by u. I'm sorry, u du. Because ln of x is u, and dx divided by x is du. So you have u du. You take the antiderivative, you have u squared divided by 2 plus c. And u is ln of x, so we have ln of x squared divided by 2 plus c. So your integration will be the integral from t to e the ln of x squared divided by 2, sorry, is ln of x squared divided by 2, and you plug in the bound, which is t and e. Okay? So you plug in the upper bound, you have ln of e squared, which is 1 squared. You plug in the upper bound, you have ln of t squared. Okay? Divided by 2. And the point is, when you let t tend to 0, the ln function will go to negative infinity. Remember that this is the graph for the function ln of x. when the input tends to 0, your function will go down to negative infinity. So that means you're gonna have 1 squared minus infinity divided by 2. So this thing is something really large. So at the end, you will have something super large and positive. I mean, minus sign gives you positive infinity. Okay, so this integral diverges. Okay, for the next one, you have the integral from 0 to infinity, and because the upper bound, I mean, this function does not have vertical asymptote, but you have the infinity on the upper bound. Okay, so we replace the upper bound by t, and you're gonna let t tend to infinity, 0 to t, x cubed e to negative x dx. And I believe for this one, you have to do the integration by part because uh, let me use x for simple. You're gonna use x, okay? And for this one, you're gonna have uh, the algebraic function multiplied with the exponential function, and you're gonna use the integration by part. So firstly, let's deal with this thing. Let's find the antiderivative of this thing. I mean, sorry, you set up u as x and dv as the rest part. So you have e to negative x dx. Okay, so you combine these two, you have du is dx and v is e to the negative x divided by negative 1. Okay, therefore, the limit that you have, the integral that we have, 0 to t of x e to negative x dx is u times v. So x times e to negative x divided by negative 1. I mean, let's put negative sign in front for simplicity. Okay, so we have negative x e to the negative x, okay, from 0 to t, minus the integration of v du. So actually, you have negative e to the negative x dx, okay? And negative sign cancel out, give me a plus sign. And take the integration, and we'll have, okay, let's plug in t. You have negative t e to the negative t. If you plug 0, this thing vanished because 0 times something is 0. For this one, the antiderivative of e to the negative x is e to negative x divided by negative 1 because of the coefficient in the front of x. 0 to t, you plug in the values, you have negative sign over here. Okay, you plug in the values, you have e to the negative t, subtract e to the negative 0, negative t, e to the negative t, minus e to the negative t. E to the negative 0 is 1. So you have plus 1 because the minus sign, And now let's compute the limit when t tends to infinity. When t go to infinity, you will have. So technically, this thing is just negative t divided by e to the t, right? Because negative powers can be rewritten in the numerators without a negative sign of power. Plus, sorry, minus 1 over e to the t plus 1. Okay. Okay, so firstly, 1 is just the number, so we don't really care about this one. When t tends to infinity, this thing will tend to 0 because you're gonna have 1 divided by something really large, so this thing is 0. But for this one, you have infinity over infinity. You have to use the power rule. I'm sorry, you have to use the Liberal rule. So I will have t to infinity of negative 1 divided by e to the t minus 0 plus 1. Okay. And finally, also here, because after I use the Liberal rules, the derivative of negative t is negative 1 is a fixed numbers, and now you divide by something real large, you will have 0. So you have 0 minus 0 plus 1, which is 1. So this uh, integral converges. Let's go into this one. So over here, I mean, when you plug in the upper bound, when you plug in the upper bound and the lower bound, you don't see any problem. But actually, this function has a vertical asymptote at 0. Okay, so therefore, you have to split the integral at 0. Okay, 0 dx over x to 1 half plus 0 to 1 dx x to the 1 half, and you're going to replace the problem by the variable t. So t tend to 0 from the left side of negative 1 t dx over x 1 half plus 0, sorry, plus t to the okay over here plus the limits when t approaches 0 from the right side of the integral from t to 1 dx over x 1 half. Okay, and the result will be t to the 0 minus the integrations of x to the power of negative 1 half will be x 1 half divided by 2 negative 1 to t. Okay, divided by 1 half, sorry, plus the limits when t tends to 0 plus of x to the 1 half divided by 1 half, the amount from t to 1. Over here, I just do the simple trick to find the integration, right? I want to find the integration of 1 over x to the power of 1 half dx. So I just simply rewrite it as x to the power of negative 1 half dx. Okay. And then we use the power rule. We add 1 into the power. So we have x to the power of 1 half, and we divide it by new power. That's how I get the entire derivative. Okay, now you plug in the bound. You have the limits when t approaches 0 from the left of t 1 half, subtract negative 1 1 half. Okay, actually the question that I create does not make sense because this is the square root. I cannot have the square root of negative numbers. So let me change a little bit. 1/3, for instance. Sorry for my for confusion. 1/3 and 1/3. So sorry, this is 1/3. Should be 1/3, 1/3. So when you do the integration, you add 1 to the power, you have 4 third divided by 4 third. Sorry, negative 1 over 3. Negative 1 over 3 plus 1 will give you 2 over 3. 2 over 3. 2 over 3. 2 over 3 and 2 over 3. So let me justify my explanation again. You have 1 over x to 1 third. Okay, so you have negative 1 third over here. So you add 1, you have 2 third divided by 2 third. Okay. Okay, 2 third, 2 third divided by, sorry, divided by 2 third plus the limit when t approaches 0 of t to the 2 third minus 1 to the 2 third divided by 2 third. Okay. And now you let t go to 0. Okay. So these two things will be vanished. Okay. And this thing gonna give you negative 1 over 2 over 2 third plus this one gonna give you negative 1 over 2 third. Okay. Actually, for this one, if you want to evaluate this one, you can think in this way. Negative 1 over 2 third is just the cube root of negative 1 square. Okay. 2 third. So the third over here becomes the cube root, and 2 over here you write again, and you have the cube root of 1, which is 1. And because you still have the negative sign in front, that's why you have negative 1. The same thing for this one. You have the cube root of 1 square. So at the end, you have 1. And you have the negative sign, you have negative 1. So over here, you combine these two things. You have negative 2 divided by 2 third. So we have negative 3 at the end. Okay, let me be more precise. You have 1 divided by 1 third. So you have 3, negative 3. Okay, 2 cancel out. Okay, how about the last one? For the last one, again, your function has a vertical asymptote at 0. So you have to split them at 0. So negative 1 to 0 dx over x4 over 3 plus 0 to 1 dx over x4 over 3. Okay. And you replace the bound you have you replace the problem that you have by t, and you're gonna evaluate the limits. So t to 0 from the left of negative 1 t dx divided x to the power 4 over 3 plus the limits when t approaches 0 from the right of t1 dx 4 third. Okay. You evaluate these two things. I'm sorry. And again, you can think the anti-derivative of 1 over x to the power of 4 over 3 is x to the power of negative 4 over 3 dx, you take the antiderivative, you're going to have x to the power of negative 1 over 3 divided by 1 over 3. Okay, you add 1 in the power, you're going to have negative 1 over 3. And negative 1 over 3 will again give you negative 1 over 3, and you have x to the power of 1 over 3, and x to the power of 1 over 3 is just cube root of x. 1, 3, cube root of x. Okay. Okay, so let me rewrite my integrations as the limit when t approaches 0 from the left of negative 1 over 3 cube root of x, negative 1 t plus the limit when t approaches 0 from the right. The integration will have negative 1 over 3 cube root of x t to 1. Okay, we evaluate the limit. You have negative 1 over 3 cube root of t, subtract negative 1, 3 cube root of negative 1, plus the limit when t approaches 0, negative 1 over 3 cube root of 1, subtract negative 1 over 3 cube root of t. Okay? So when you let t tend to 0, you have negative 1 divided by something like 0, right? Okay, so you have something, you have a negative number. You have a negative number divided by something really, really small, but negative. Okay, because this is t, this is 0 from the left side. So that means you take negative 1 divided by something that really, really small. Okay, negative sign cancel out. Give me the plus sign. And 1 divided by something really small will give you positive infinity. The same thing for this one. When t approaches 0 from the right, okay, you have negative 1 divided by something really, really small, but on the right side of 0. So they cancel out. So you have the negative numbers divided by something really small. You're going to have the negative infinity, but with the plus sign over here, you have the positive infinity. So you have positive infinity. So at the end, your final result will be positive infinity. Okay? So you can use the idea to solve the similar questions on your written assignment. Okay? So we've done with the recitation video. And if you have any questions, feel free to email me. Okay? And I will see you in the next material.